Hey everyone, welcome back from another break. We are going to finish out the chapter this week with 8-4, 8-5, and 8-6. It's going to be a little bit more difficult than 8-1 and 8-2, so just do the best you can, okay? And then when this is done, after you've taken notes, you're going to want to try the textbook problems for this section and drop box those to School Loop, okay? So we're going to start with rational expressions. Rational expressions, basically just a fraction. That's all it is. Rational expression means a fraction, okay? And today we're going to be simplifying them. So in the easiest form you have done before would be something like if we wanted to simplify 4 over 10, okay? We could simplify this. We look for what's in common or what we can reduce. Let's say in this case by 2. We can reduce the top and bottom by 2. And when we do that, we get 2/5, and then we have a simplified fraction, okay? And that's because 2 doesn't go into 5, and there's no other factors that we can reduce to, okay? So that's what we're going to be doing. We're going to be reducing to simplest form. If we come over here, the ones that are not in simplest form, though, it gets a little bit more challenging when we're looking at variables. For this first one, x over x squared, okay? These are common variables that we can simplify, and hopefully you notice with x over x squared, like that this is x to the first, and if you remember our exponent rules, we can subtract our exponents. So 1 minus 2 is going to be -1, but we don't like negative exponents, so it stays on the bottom. Or you can think of it as, okay, 2 minus 1 is 1, and the bigger one's on the bottom, so it stays on the bottom. And so what we have here is on the bottom we have x to the first. We don't have to write the first. And then on top, when there's nothing left over, it's a 1, because everything cancels to 1 when you simplify, okay? So that would be a simplified form of something like that. Now, when you get to the second one, 3 times x minus 3 over x minus 3, okay? A lot of people make the mistake of saying, oh, okay, look, x divided by x is 1, -3 divided by -3 is 1, and that's going to simplify in that way. But that's not how it works, okay? We can only simplify factors. So if I come back up here, okay, my factors of 4, okay, can be 2 times 2, and then factors of 10 are 2 times 5, and then what we're really doing is canceling 2 divided by 2 is 1 to be left with 2/5, okay, same answer, right? So we can only cancel factors. Oops, notice those factors are there from multiplying, okay? And so when you think of factors, think of multiplying. So when I come here, I see multiplying this 3 times the x minus 3. And so we're multiplying times all of this x minus 3. Now this x minus 3 is called a factor, okay? Whenever you see pluses and minuses, think of those variables and numbers as joined together. They're linked together with the pluses and minuses, and it creates its own factor. The only thing you can factor with an x minus 3 is another x minus 3. It has to look exactly the same. And so when I'm canceling here, what I'm actually reducing is this entire x minus 3 is reducing with this entire x minus 3, so that the only thing that you're left with is a 3 on the top. Okay? And so you can only cancel factors or reduce factors. You cannot cancel like an x and an x minus 3 and x minus 3. Okay? Which brings, and we're not going to do that last one because it's not a good one. Which brings me to this on the left side over here where it is in simplest form. Okay? So if I look at this first one, we have x plus 1. Oops. We have x plus 1, and then down below we have x minus 1. And again, a lot of people think, oh, I know what I can do. I could probably cross these both off and get -1. And again, that's not how it works, okay? The only thing I can cancel with an x plus 1 is another x plus 1. And the only thing I can cancel with x minus 1 is another x minus 1. That entire factor, because it's joined together with the plus or with the minus, okay, has to be exactly that factor in order to cancel. Okay, so again over here, sometimes we'll have to do some factoring in order to get the factors, right? So like on this one, we would add to 3 and multiply to 2. We'd have x plus 2 and x plus 1, okay? So these are factors, okay, because you can see there's multiplication here, and down below we have another factor of x plus 3. Okay, and that one is completely different than the x plus 2 and the x plus 1, so there's nothing to factor. This would be a simplified rational expression. There's nothing you can do, okay? We're going to look more at this as we look into our examples. So Okay, we're going to simplify these rational expressions. Sometimes we will need to factor either the numerator or the denominator. Okay, that will have to happen. We'll have to do some factoring. Okay, and what we're also going to do as part of this is state any restrictions. Okay, we're going to state the restrictions on the variables. Restrictions come in because we can't have the denominators equal to 0. Okay, if there is a denominator equal to 0, then the fraction has a 0 in the denominator and it's an undefined fraction. So we'll look at restrictions in just a moment. Right now, let's start with a. Okay, and so if I look at a, I have 24x cubed y squared. Notice it's 25 times x cubed times y squared. And on the bottom, it's negative 6 times x squared times y cubed. All this multiplication means all those numbers and variables are factors of each other. So you can go straight into reducing everything. Okay, so like negative 6 can go into 24 a negative 4 times. Okay, and then x cubed divided by x squared. This is where you're subtracting the exponents, okay? 3 minus 2 is 1. The 3 is bigger, so it goes on the top. You have an x to the first. And then y squared over y cubed. Again, 3 minus 2 is 1, but the 3 is bigger. It's on the bottom, so we're going to keep it on the bottom, okay? And you've gone through and you've simplified all the numbers you can and all the variables that are like variables. And so on the top, what you're left with is a negative 4 and also an x to the first. It's all being multiplied. And on the bottom, all you have left with is y to the first. And there is your simplified rational expression. I can no longer reduce this in any way, okay? Now, with that, we need to think about our restrictions because there are certain numbers the variables cannot be, so we do not get an undefined fraction, okay? And so what we're looking at is the denominator, and we're looking at the variables. And in something like this, where we don't have to solve anything per se, okay, we didn't factor anything, what we're looking at is x's and y's. X can't be equal to 0, and y can't be equal to 0, okay? And so these are your restrictions, because if I tried to plug in 0 for x squared right here, 0 squared is 0, 0 times negative 6, and y cubed is going to be 0, okay? And if I tried to plug in similarly 0 for y, 0 cubed is 0, 0 times x squared and negative 6 is also 0. And so we're avoiding the zeros in the denominator, and that's what our restrictions are. We can't have those numbers in the denominator. It's always from the original expression though. It's always from the original, not the end result, okay? So we can't have x be 0, we can't have y be 0, okay? Let's try one more of these. If you go down to the got it, we'll do D together, okay? And so if I look at this one, same idea. We have 9 times a to the 4th times b to the 7th, and 18a squared times b to the 9th. So these are all factors that you can reduce and cancel. So like 9 goes into 18, it goes in 2 times. Think of it as 1/2, okay? A lot of people tend to write the 2 on the top just by mistake, but remember the bigger number is 18, so when 9 goes into the 18, that's 2 left over, so the bigger number 18 is on the bottom, and the 2 goes on the bottom, okay? A to the 4th and a squared. Again, we subtract those exponents. We're left with an exponent of 2 on the top because 4 is bigger. And then for b to the 7th, b to the 9th, 9 minus 7 is going to be 2, and 9 is bigger, so the 2 goes on the bottom. Okay, and so your final answer here, we have, let's see, an a squared on the top, okay, and then on the bottom we have a 2b squared. And that is our simplified fraction. Okay, and we're done with that problem. There's nothing else that can be simplified. Of course, don't forget the restrictions. Okay, the restrictions, it's where the denominator equals 0. So for a squared, a can't be 0. And for b, or excuse me, yeah, it was a squared. And then b to the 9th, b can't be 0 again, okay, because 0 to the 9th power is 0. So those are your restrictions. A and b can't be 0. Your restrictions, again, come from the original expression, the original problem, okay? And so those aren't too bad. You're just reducing the same variables and the same numbers, okay? But let's say we come up here to b. Now we have x squared plus 2x minus 8 over x squared minus 5x plus 6. Don't write this, but a lot of people want to do this. X squared divided by x squared, 8 divided by 6, we'll get 4/3 or something like that. That is not how it works because these are not factors here. See how the pluses and minuses, it joins them together, so they're not factors. So what we are going to do is factor it. Okay, we are going to factor it. We can add to 2 here and multiply to -8 on the top. And so if I do that, let's see, what is it? It's a +4 and a -2, so x plus 4 and x minus 2. Okay. And then on x squared minus 5x plus 6, again, same idea. We're going to add to -5 and multiply to 6. And so that seems like 2 and 3, but -2, -3 because we are adding to -5. So it's x minus 2 and x minus 3. That adds to -5 and multiplies to and then multiplies to +6. Okay. And so now I completely factored it, and hopefully you see now in between these parentheses here we have multiplication, and multiplication creates factors. Factors are what you can cancel. And so what I can cancel? Well, I can't cancel an x plus 4 because there's not another x plus 4. But if I look at the x minus 2, I can cancel x minus 2 with x minus 2 here. I'm canceling the entire x minus 2 with another entire x minus 2. Okay? And that's it. We are done there. Okay? Because on the top I'm left with x plus 4. You can put it in parentheses if you want. You don't have to. And then x minus 3 on the bottom. These are completely different factors. You cannot simplify them anymore. You are done at that point. Okay? Now restrictions. Okay? Again, it's where is the denominator going to be equal to 0. Okay? We want to set this equal to 0. So x squared minus 5x plus 6 equal to 0. Okay, this we've done a long time ago. Again, factored, which we've already seen the factored form. It's x minus 2, x minus 3. We saw that above. And then to solve here, right, we make x minus 2 equals 0 and x minus 3 equals 0. And we solve, we get x equals 2 and x equals 3. Well, this is what x cannot be. X cannot be 2 and x cannot be 3. Those are your restrictions. If you tried to plug in 2 or if you tried to plug in 3, x can't be 2 or 3. What you'd get in the denominator is 0. Okay, so it's where the denominator is equal to 0. It's a little different than A. Right? We had to solve on this one, where in A, you didn't have to solve anything. It was just x couldn't be 0 and y couldn't be 0. Okay. So again, we're factoring, so we can find the factors and cancel those factors that are exactly the same. Okay. Go ahead now on the got it. Try E really quick. Try pause this and try got it E. You're going to have to factor the top and factor the bottom and see what you can cancel. So pause it and try it on your own. Okay, now hopefully when you come back, you'll see a couple of things here. I'm going to erase so that I can talk to you about it. Okay. All right, so if you factored the top, you got x plus 5, x plus 2, and the bottom x minus 5, x plus 2. And so hopefully you see that you can cancel x plus 2 and x plus 2. Those are exactly the same factors that can be canceled, and you're left with an x plus 5 over x minus 5. These are completely different factors. Just because they have the same x's and the same 5's does not mean they're the same, okay? X plus 5 here and x minus 5 are completely different factors. So they do not cancel. That is your answer there. And then the restrictions, again, you're looking where this denominator is equal to 0. So that's where x minus 5 is 0 and x plus 2 is 0. And that's x can't be 5 and x can't be -2. So hopefully you got all that. Okay, because we're going to keep going. And we're going to look at this problem right here, C. Before we try this problem, can you please change 12 minus 4x to 12 plus 4x, okay? So it's going to be a plus 4x in the middle. All right, so go ahead and change that, okay? And then we'll start. Okay, So 12 plus 4x over x squared minus 9. You, again, do not try canceling like this x into this x squared, etc., etc. That is not how it works, okay? You have to factor these. When you see pluses and minuses, try to factor. Now, we did this kind of factoring where we're adding and multiplying, but we haven't done this type of factoring yet. This one here is going to be a greatest common factor. That's all you can do. Okay, there's going to be a few problems in your homework. You will need to do greatest common factor. Now on the bottom, it's going to be a difference of squares. Okay, we haven't done that one in a while, so we'll look at all of this. So on the top, my greatest common factor is going to be a 4, and if I take that out, it looks like I'm left with 3 plus x. Okay. On the bottom, my difference of squares, it's been a while here, but the square root of x squared is x, and the square root of 9 is 3. So x and 3, one is plus and one is minus. It doesn't matter which one's which. Okay. All right, so now that everything's factored, I say I have 4 times 3 plus x and x plus 3 times x minus 3. So you can see all these multiplications. That's where it breaks up all your factors, okay? And hopefully you see that 3 plus x is also the same as x plus 3 because addition is commutative, okay? Only addition is, not subtraction. In that x plus 3 can cancel with x plus 3 here. And so you're left with just 4 on top and x minus 3 on the bottom. Okay? And that's it. You were done for that problem. You do need to figure out the restrictions. The restrictions are going to be in the original, whereas x squared minus 9 equals 0. Okay? You have the factors already, x minus 3 and x plus 3. They were found above. And then hopefully you see that here you're not going to get, you're going to get x can't be 3, and you're going to over here get x can't be negative 3. And those are your restrictions. Okay. Okay, before we go, we're going to do one more problem. I'm going to want you to just kind of write it over here. Find some blank space, and we're going to add an extra example. Okay, and I want to do 2x divided by 4x squared plus 10x. So this is the problem I want to do. Okay, please add that somewhere on your sheet. Okay. And we will start. The 2x cannot be factored, okay? There's a 2 times x, there's only those factors. But the bottom, I can do a greatest common factor. So I will do that. So on the top, I have 2x. On the bottom, I have, let's see, I'll take out a 2x also. And I'm left with 2x plus 5. Okay. Okay. So hopefully you see that there's a 2 times an x on the top and a 2 times an x plus 5, okay? So wherever that multiplication is are your factors, and then you can cancel and reduce factors. So I see now 2 divided by 2, each of those factors can cancel, and x divided by x, each of those factors can cancel. And so what I'm left with, when nothing is left over, whether it's the top or the bottom, it's a 1, okay? Because 2 divided by 2 is 1. X divided by x is 1. So when we cancel to 1. And that's 1 over 2x plus 5. And that is your simplified form. Again, if you want to put 2x plus 5 in parentheses, you're more than welcome to. Okay? And then the last part for this problem are the restrictions. Okay? Don't forget about those. It's important to understand what x cannot be, so we don't plug those values in. Okay, let me fix that over here. Okay. So on our restrictions, it's where our original denominator is equal to 0. So that's 4x squared plus 10x equals 0. And we already have that factored, 2x and 2x plus 5. Okay. And so we are going to make our table. It's either where 2x is equal to 0. Okay. And when I divide by 2, x is equal to 0. So x can't be 0 is one restriction, and then 2x plus 5 equals 0. So I'll subtract the 5, 2x will equal a negative 5, and divide by 2, and x is equal to a negative 5 halves, and there is our other restriction. So x can't be a negative 5 halves, and x can't be 0. Okay, and that's the restrictions on those. So in your homework, you will need to do restrictions, okay? I'm just going to move this a little bit over here. You will need to, move the state the restrictions. You will also need to simplify the problems, and I think you only have like 4 or 5 homework questions. It's not a lot, okay? So do the textbook assignment, Dropbox only the textbook assignment to School Loop when you are done, and everyone have a great day, and we will talk soon. Bye-bye.